Hello friends, this video on metal and non-metal part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. We have learned some chemical property of metals. Now we'll learn the reactivity of metal. Some metals I told like sodium are reactive. Other metals like gold, silver, they are less reactive. So there has to be a reactivity field. We can tell that okay, this guy is more reactive than this guy is less reactive than this guy. So to define this, like we have to create a table on the reactivity of metal. We'll do that. So we'll start with that. So the first thing we'll do that we'll try to react metals with oxygen, and we'll see that because oxygen is freely available, right? To react with oxygen, the only thing you have to do is you burn it. That's all. The moment you burn it, oxygen is there, it reacts with oxygen and forms something. So we'll react with oxygen and see how it behaves. So we'll do the experiment. I'm not doing in front of you, but the observation you can see is you have a lot of metals, right? So you'd first take potassium and sodium. You see that these guys react so vigorously that they catch fire even if they're open, kept open. So you take out sodium that is dipped in kerosene oil. Why does dipped in kerosene oil? Is because sodium is so reactive that the moment it comes in contact with moisture or oxygen, it reacts, right? So to prevent that, it is kept in kerosene oil so that it should not get exposed to oxygen or water. So they are so reactive that the moment they come out of kerosene, they catch fire. That moment itself, they for example, they react with water to give this guy NaOH plus H2. So they are so reactive. They are metal, but they are very, very reactive. Next kind of metal, if you see this, manganese, aluminium, zinc, lead. These metals, they react, but they don't react much because they form an oxide layer to prevent further oxidation, and that is called anodizing. We'll learn that in the next slide. So the moment they react, for example, aluminium, it creates Al2O3 oxide, and that is a protective layer that this guy doesn't react more, right? So end of the day, the aluminium metal doesn't react much because it has this aluminium coating. So with this, I'm trying to say that I can't use this oxygen kind of parameter to find the reactivity of these metals. Why? Because after some time they stop reacting because of the creation of this aluminum oxide when you burn this in front of with the presence of oxygen, right? The other kind of metals like iron, even if you heat, it won't burn, but if you put this in some flame where it has high temperature, it will react. It will react, right? So then copper is something which doesn't burn, right? But if you see, when you heat it, it gets a coating of a black layer of copper oxide. Copper oxide it gets. So that means it reacts, but it doesn't burn. It doesn't burn, but it gets a copper oxide layer. And if you see silver and gold, they don't react with oxygen at all, even in high temperature. So if you see from this, we can say that sodium and potassium are in one group. Then we have this aluminium, magnesium, zinc. Then we have iron, then we have copper. And then we have silver, gold. So this is kind of reactivity series for the metals, but we are not very much sure on where the potassium and sodium falls. First potassium comes, the sodium comes. First manganese comes, the aluminium comes. But we have vague idea of like this guy may be in the top, this guy may be in the second top, this guy in third, this guy in fourth, and this guy may be in the fifth. But we don't know the actual position, right? So with the oxygen thing, we have a lot of vague idea on the reactivity of the metal. That is, potassium and sodium are very reactive, and the gold and silver are less reactive. But the exact series we are not able to find yet, right? We have got some vague idea. So let's do something else to find the exact series. But before that, let me take you to the definition of energy. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.